Ever wondered if a cat could be both alive and dead at the same time? Welcome to the bewildering world of quantum physics. This isn't your typical high school science class. Quantum physics is a branch of science that deals with the smallest particles in the universe. It's like peeking into the essence of reality itself, but it's far from simple. It's abstract, it's complex, and it's downright counterintuitive. But don't worry, we're not going to leave you in the quantum dust. We're going to explore this fascinating field through a curious little thought experiment that's become quite famous. Perhaps you've heard of it. It's called Schrödinger's cat. This peculiar feline finds itself in a rather unique predicament, straddling the line between life and death. But how is this possible? How can something be two contradictory things at once? Stay tuned to unravel the mystery of Schrödinger's cat. In the strange world of quantum physics, a cat can be both dead and alive. Sounds intriguing, doesn't it? Well, sit back and let's unravel the mystery of this curious concept known as Schrödinger's cat. Our story begins with a man named Erwin Schrödinger, a brilliant physicist from Austria. Born in the late 19th century, Schrödinger became a key figure in the development of quantum physics, a field of science that explores the peculiar behaviors of atoms and particles. In 1935, Schrödinger proposed a thought experiment involving a cat. Now, this wasn't any ordinary feline. This cat was trapped in a box with a vial of poison that could be released at any moment. According to quantum theory, until we open the box to check, the cat exists in a state where it is both dead and alive. Schrödinger proposed this experiment not because he had any ill will towards cats, but to highlight the paradoxes and complexities of the quantum world. This experiment, which never actually took place, thank goodness, has since become a cornerstone of quantum physics. It's a demonstration of a phenomenon known as superposition, where particles can be in multiple states at once, until observed. This paradox challenges our everyday experiences and our understanding of reality. It forces us to question, how can something be in two opposite states at the same time? Is reality really as it seems? Or is there more to the world than meets the eye? Schrödinger's cat is a powerful analogy that has sparked countless debates and has inspired further exploration into the quantum world. It's a concept that continues to baffle scientists and laymen alike, reminding us that there's still so much more to learn, to question, and to discover. But how can a cat be both dead and alive? Let's delve deeper. Imagine a cat, a flask of poison, and a radioactive source all inside a sealed box. What happens next? Well, we're about to dive into one of the most mind-bending concepts in quantum physics, the quantum superposition. Picture this. Our feline friend is in a box with a radioactive atom that could decay at any moment. If it decays, it triggers a mechanism to break the poison flask, and alas, the cat meets its untimely end. But if the atom doesn't decay, the flask remains intact, and our cat lives to see another day. Now, here's where things get a tad peculiar. According to classical physics, the cat is either alive or dead, based on whether the atom has decayed or not. But in the wacky world of quantum mechanics, the atom is in a superposition of states. It's both decayed and not decayed at the same time until we check it. And this is where our cat comes in. Since the cat's fate is tied to the atom, it too is in a superposition of states. That's right, until we open the box, the cat is both dead and alive. It's only when we open the box and observe the cat that it snaps out of this superposition and becomes either dead or alive. This is the essence of the Schrödinger's cat thought experiment. It helps us understand the bizarre nature of quantum superposition, where particles can exist in multiple states at once until they're observed. It's like the universe is keeping all its options open until it absolutely has to choose. So, next time you see a cat, remember, in the quantum world it could be both dead and alive. And that's the magic of quantum superposition, a concept that takes us a step closer to understanding the strange yet fascinating world of quantum physics. So, until we open the box, the cat remains both dead and alive. But wait, does the act of observation affect the state of the cat? You might think that's a strange question. After all, in our everyday world, observing something doesn't usually change its state. If you look at an apple, it doesn't suddenly become an orange. But in the realm of quantum physics, things aren't quite so straightforward. Enter the observer's effect. This fascinating concept suggests that the very act of observing can influence the state of a quantum system. And it's not just about changing the state after you've observed it. No, the act of observation itself is what causes the change. Imagine you're observing Schrödinger's cat. Before you open the box, the cat is in a state of quantum superposition. It's both alive and dead at the same time. But the moment you open the box and observe, the superposition collapses into one of the possible states. either alive or dead. This is the crux of the observer's effect. Your active observation has influenced the state of the cat. But how can this be? You didn't physically interfere with the cat or the box, all you did was take a peek. Well, quantum mechanics is a bit of a rule breaker. It doesn't play by the same rules as classical physics. In fact, it's got its own set of bizarre and counterintuitive principles. And the observer's effect is one of them. So what does this mean for our poor hypothetical cat? Well, it seems that its fate is tied to our curiosity. If we decide to observe, we force the superposition to collapse into a single state. But if we refrain, the cat continues to exist in its eerie state of being both alive and dead. In essence, quantum mechanics gives us a strange kind of power. Our mere act of observation can influence the state of quantum systems. It's a concept that's as fascinating as it is perplexing. It seems our mere act of curiosity can determine the fate of the cat. What if I told you, in another universe, the cat might have a different fate? Welcome to the peculiar realm of the many worlds interpretation, an intriguing twist in the tale of Schrödinger's cat. To understand the many worlds interpretation, or MWI, we need to step beyond our conventional perception of reality. In a nutshell, MWI proposes that with each quantum event, the universe splits into multiple parallel universes, each representing a different outcome of that event. It's mind-boggling, isn't it? But that's quantum physics for you. Now, let's bring back our feline friend. Remember, in Schrödinger's thought experiment, the cat's fate hangs in the balance, determined by the quantum superposition of a radioactive atom. According to the MWI, at the moment the box is opened, the universe bifurcates into two parallel universes. In one, the cat is alive. In the other, well, not so lucky. The beauty, or perhaps the bewilderment of MWI, is that it resolves the paradox of the cat being both alive and dead before the box is opened. Instead of the cat's state being undetermined until observed, MWI says the cat is unequivocally alive in one universe and unequivocally dead in another, and each of these realities exists in a separate parallel universe. But what does this mean for us, the observers? Here's the kicker. According to MWI, we also split along with the universe. In one universe, you're the version of you who finds the cat alive. In the other, you're the version who finds the cat. Let's just say, less than alive. The many worlds interpretation is indeed a fascinating, though controversial, perspective. It pushes us to rethink the nature of reality and our place in the cosmos. And it gives our hypothetical cat not just 9 lives, but an infinite number of them. So, in another universe, our cat could be sipping milk happily, or not. And that, my friends, is the many worlds interpretation in the enigmatic world of quantum physics. If you're enjoying this quantum adventure, why not become a part of our community? By subscribing, you're not only showing your appreciation for the work we put into these videos, but you're also ensuring that you won't miss a single quantum leap into the fascinating world of science. Think of it as a ticket to a never-ending science expedition where we unravel the mysteries of the universe together, one video at a time. It's like having a front-row seat to the greatest show in the universe, the spectacle of science. Every subscription helps us generate more content, delve deeper into complex topics, and share our passion for knowledge with more science enthusiasts like you. So, are you ready to hop onto this quantum roller coaster that takes us from the infinitesimal particles to the vast expanses of the cosmos? Don't miss out on our future quantum journeys. Subscribe now. So, let's summarize our quantum journey with Schrödinger's cat. We began with a curious question about the nature of the quantum world, and we found ourselves in a paradoxical universe where a cat can be both dead and alive at the same time. A place where the normal rules of reality don't apply. In our exploration, we delved into the concept of quantum superposition, a principle that allows particles to be in multiple states at once. We learned that it's not until we make an observation that these possibilities collapse into one outcome. This is known as the observer's effect, and it's one of the most mind-boggling aspects of quantum physics. We also discussed the many worlds interpretation, a theory suggesting that all possible outcomes of a quantum event actually occur, but in separate parallel universes. It's a concept that challenges our understanding of reality and offers a fresh perspective about our place in the cosmos. And let's not forget about our fuzzy friend, Schrödinger's cat. This thought experiment, while seemingly absurd, helps us grapple with the abstract nature of quantum physics. The cat, trapped in its box, is both dead and alive until we look inside. It's a concept that forces us to rethink our understanding of reality. So, what have we learned? Quantum physics is a field full of paradoxes and complexities. It challenges our everyday understanding of the world and forces us to think in new, exciting ways. It's a realm where cats can be both dead and alive, where particles can be in two places at once, and where observing something can change its state. But remember, as strange as all this might seem, it's this very strangeness that makes quantum physics such an intriguing field of study. It's a world full of possibilities, a world where the impossible becomes possible. And that, my friends, is the curious tale of Schrödinger's cat. Quantum physics might seem abstract, but it's part of the fabric of our universe. Schrödinger's cat, a thought experiment we've explored today, is a whimsical yet profound illustration of this reality. It's a concept that's as fascinating as it is mind-bending, a concept that challenges our everyday perception of the world around us. You know, quantum mechanics isn't just about a hypothetical cat in a box. It's about the particles that make up everything we see, touch, and experience. It's about the tiniest building blocks of matter and how they behave in ways that seem downright impossible by classical physics standards. But why should we care? Why should we invest time and brain power into understanding these seemingly abstract concepts? Well, the answer is simple. Quantum physics is not just a theory, it's not just a field of study reserved for scientists. It's a fundamental part of our universe and, by extension, our very existence. As we delve deeper into the quantum world, we start to realize that we are not just observers of this universe but active participants. The observer's effect, the concept that simply observing a quantum system can change its state, is a testament to this fact. Our exploration doesn't have to stop here. There are many more quantum concepts to delve into: quantum entanglement, quantum tunneling, quantum computing, and the list goes on. Each concept is a piece of the puzzle, helping us understand the universe and our place within it. In the end, it's not about finding definitive answers, but about asking the right questions. It's about nurturing our curiosity, opening our minds to new ideas, and embracing the mysteries of the universe. So, don't shy away from the complex and the unknown. Embrace it, explore it, question it. After all, the universe is a vast, intriguing place, and there's so much more to discover. Thank you for joining us on this quantum journey. Until next time, keep questioning and keep exploring.